Tom Worley from FOSS365. This will be a series of tutorials on how to get started with writing GLSL code for the Shadertoy node in Natron. Now, I'm completely new at this, so this series is really going to be a wing it series. So, seeing how I don't know what I'm doing, I figured it might be good for anybody that wanted to follow the journey. Just they can watch the videos and follow along. So I guess the first few things I'm going to do to just get a handle on what's going on with the Shadertoy node is to go to the Shadertoy website, and they have a tutorial set up that we can go through. So let's go ahead and type in Google Shadertoy, and we want tutorial, and it will bring up a GLSL 2D tutorials, and you can click on that and it brings up this page. Now this page goes through a bunch of things that we can do right here on the Shadertoy page to kind of learn GSL code. But we can, I guess, get a little bit more benefit out of it by taking some of this code and pasting it into Natron. So I guess this tutorial starts out with just this flashy screen, but if we want to walk through them, the very first tutorial is void. In other words, we're going to create a blank screen. Doesn't that sound interesting? So that's tutorial number 1. So we need to change the definition for the tutorial to 1 up here, and then come down here and recompile the code and press this compile button or the play button, and when we do, the screen should go black. And it does. So why is it going black? Well, we come down here and we look for the definition for tutorial 1. And all this is going to do is void blank screen. So in GLSL code, the main function is called several times. So it looks like we've got a main function here, and this is called several times to produce a speed of 60 frames per second. But of course, if you have a ton of computations, the frame rate is going to drop. But basically, it looks like this code right here should create a black screen. These 2 slashes means that it's nothing more than a comment area. So really, the only code in here is that right there. So let's copy all of this. If we copy this, it should be able to go into Natron as is. So let's add a shader node over here. Press tab and pull in Shadertoy. I don't think I need my key monitor, but I'll throw it in there just in case. So if we hook up the Shadertoy, it has some default effect, right? And we know what that is. It's just some colors changing in a crosshatch pattern. So, but that's the default behavior of the Shadertoy node. And it looks like it's got a bunch of connections too. So if we double left click on that, come up here to where it says image shader and expand that, here's all of the GLSL code right there that makes this happen. So what we want to do is delete that. So there's no code in here at all, right? And I think we already copied it, but just in case we didn't, come back over here, right click copy, and then go back to your Shadertoy plugin, right click, I can't right click, just make sure that's highlighted and press Control V to paste, and now you paste that code in there. See, it's the exact same code, void blank screen, and it's got the main function right here that does nothing more than make this a black screen. So when we click out of here, we can click compile, and when we do, the screen should go black, and it does. But we still have all these connections here, and that's because we didn't reset the parameters and then click auto parameters. If we do, all the connections should go away because we're not using any connections in this code. Let's try it. Reset parameters and then auto parameters. Yep. See how on the Shadertoy, all of these channels basically disabled. They're still here. iChannel 0, 1, 2, and 3, they're still here. They're just disconnected. So guess what? This is sort of like the hello world of code for GLSL shaders. So you've just done your first coding in GLSL. Woo! I don't know, goofy, I guess. But all right, so let's continue on here. And let's go up to the top. Let's click 2. Go on to the next one. Come down here and compile it by pressing this compile button. When we do, screen actually turned a different color. That's cool. So let's go down to 2 and see what it says. So yeah, there you go, solid colors. So the frag color is the output variable of the shader. Its value determines the image on the screen. This shader sets the value to the yellow color. So it looks like when we return looks like, what do we have? We have a vector 4 that it's returning called frag color. So it looks like we have a vector 4, right? And that vector 4 is got a value of 1, 1, 0, 1. So what does this mean right here? That means that we're breaking up the image into a red channel, a green, and a blue channel. And the last channel is your alpha channel. All of these values will be from 0 to 1, with 0 being totally black, or I guess totally dark, and 1 being the brightest value for that channel. So it looks like in the red channel we've got that totally bright, and in the green channel we have that totally bright as well, and red and green, and the blue channel is 0. So that means that we have no color at all. So it looks like red and green give us yellow. And 1 just means that our alpha channel is going to be totally opaque. That is, we can't see through it. Okay, we probably won't be messing with the alpha channel in this tutorial at all. At least I went through a few and I didn't see any. So if we copy this and we put this into the Natron Shadertoy, so we come over here, right, and we take all of this code that we had in there previously and we delete it, and we press Control V to paste in the new code, right? So this one is the frag color where it's yellow, and if we press out of this box here, the compile button shows up, and if we click compile, we get an error. Why is that? Unmatched elif. Okay, looks like I yanked in the elif too. Yep, I did. You may do this too. Just get rid of that elif. The very first line of code needs to be your / so that all of these are comments. So all of the comments are there, and really the only function we have is the main function right here that's returning a vector 4 called frag color that is the color yellow because we got red, green, totally bright as it can be, and the blue channel is totally black or dark. Okay, so now if we click out of that and press compile, yeah, it's yellow. So we can see that if we come over here, and let's change that to a 0. Now I should just get a color of red, right? Because the only value I'm using in here at its brightest value is the red channel. So if I click out of here and I press the button, compile button, yeah, there we go, it's red. So that's pretty cool. So we change the color to red, or if we want, we can put a 1 here. And now with the red channel and the blue channel are completely at the highest value they can be, and I compile it, and then it's purple, exactly what I thought it would be. So you can change the color of your background just by coming in here and pressing those values. Okay, so this is step 2. Let's go to step 3. Let's see what step 3 is, or tutorial 3, I should say. Let's go to tutorial 3 and compile it. What do we have? It just looks like another solid color. Well, let's go down to 3 and see what it says. So 3, there's all the code for 3. There's our main function that gets called over and over again, right? So GSL vectors, frag color, should be assigned a vector 4 object, which we saw in the previous one, right? The vector 4 color is being returned from the function and setting the color. So let's see what we got here. That's nothing new. Frag color should be assigned a vector 4 object, which is made of 4 numbers between 0 and 1. We already talked about that. First 3 numbers determine the color. Yeah, we talked about that. The red, blue, and green channel. And the 4th number determines the opacity. Yeah, or the alpha channel. We talked about that too. For now, changing the transparency value will have no effect. A vector4 data object can be constructed giving 4 float arguments, or 1 vector3 and 1 float argument. So let's take a look at what's happening. In this one, right, they just assigned the frag color a vector4. That's what happened up here with 4 different float values. Well, down here they're just showing you that you can do the exact same thing by the comment right here. Here we are separating the color and the transparency parts of the vector4 that represent the pixels, right? So in our main image, we're creating a vector3. A vector3 expects 3 floats. There's 1, there's 2, there's 3. So we're creating a variable, a vector3 variable called color, and we're assigning that a vector3 that has 0 for the red channel, right? 1 for the green, and 1 for the blue. Okay, so we're defining our color here, and then we're creating another float called alpha that we're going to use for the alpha channel. And then down here we're creating a vector4 variable called pixel, and we're assigning that pixel the combination, right? We're creating a vector4 here, and color is defined up here as 3 different float values, right? So we've got 3 different float values here, comma, 1 more float called the alpha. There's the alpha as set to 1. It's right there. So this vector4 actually has 3 values. There's that first value, second value, third value, and fourth value, right? So now pixel is a vector4. So now down here we say frag color is going to equal, or is going to be assigned the value of our pixel variable. So it's going to have a value of 0 in the red, 1 in the green, 1 in the blue, and 1 in the alpha. So that's why we're seeing kind of this aqua color, because we've got full brightness in the green and full brightness in the blue. That's why you see that there. So if we take this and we copy that, I know this is kind of mundane, but repetition helps to kind of solidify what's going on. So we're going to paste that in here with a Control V and make sure that we start with the comments, and we are. I'm going to come out of here and I'm going to click compile. Bang, there you go. It's blue. So now this vector3, we could mess around with it, and if we put another 1 here, what color do you think that's going to be if everything's full brightness for the red, green, and blue? Yep, you got it. It's going to be white. We click compile and it's white. So we're moving right along. I mean, we're starting to understand it, right? There's a main image function that gets called over and over again that creates the image for us, and this function expects a vector4 returned in the form of a variable called frag color, right? So cool. All right, moving along. Let's go to number 4. I'm not sure what number 4 is, but let's see what it does. Okay, we get another solid purple screen. Let's come down here and see what number 4 says. So, well, we're starting to add a bunch of stuff, bunch of code inside of our main, that's for sure. So, RGB color model and components of vectors. After initialized, the components of the vectors can be reached using the dot notation. Okay, so a color is represented by 3 numbers, here in the range of 0 to 1. The model assumes the addition of pure red, green, and blue lights of given intensity. So we already talked about the different channels. If you lack design skills like me and have a hard time in choosing nice looking coherent set of colors, you can use one of the websites to choose color palettes, blah blah blah. Okay, so in our main image function, we are looking at the comment here. It just says play with these numbers. So we've got a float that's going to represent the red amount. That red amount is 0.6, and we've got a green amount that's 0.2 and a blue amount, right? So we just have float variables that are assigned a value here, a float variable called red amount, green amount, and blue amount, and they're being assigned certain values here. And we've got a vector 3 color, and it equals a vector 3 0 0. So we're just creating a variable called color that's basically going to hold a vector 3, right? But this looks kind of weird, doesn't it? Because we kind of expect this to have 3 different float arguments. So what the heck's going on? Well, this is kind of shortcut for saying the exact same thing as this. So it says vector 3 0 0, but we could say comma 0 0, comma 0 0. Okay, so it's the Shadertoy node and this Shadertoy website. These two syntax mean the exact same thing. Vector 3 with a 0 0 0 is the exact same thing as if I just say vector 3 equals 0. What I'm saying here is no matter what value I put in here, use the same value for all 3 float values for my vector 3. So this color is going to equal 0 0 0 for the red, green, and blue channels, even though you didn't type that out here. So that's a bit confusing if you didn't look in the document to see exactly what's going on. I suggest if you're new to coding, go ahead and put that in there, because watch, we'll put comma 0 0, comma 0 0, and sometimes it's good to code long form so that it gives you the readability that you're used to. Okay, so now if I click the compile button, watch, it's still going to be purple. Nothing changes. It's just 2 different ways to do the exact same thing. So having said that, this color has no value, right? The red, green, and blue channels are all 0. So now we come down here and it looks like the color variable, right, has the ability to use, and that's what they're talking about up here, dot notation to get to a, I guess, secondary variable. So color dot x is going to be the first channel. That's this channel right here, right? So we're saying that color dot x channel is going to be whatever we assign to the red amount. And what did we assign to the red amount? Let's look up here. The red amount was 0.06. Okay, so at this point we're going to say color.x, or this first float value here, is going to equal our red amount, 0.6. Okay, and same thing with color.y, which is going to be the second value here, is going to equal the green amount, which is up here. Green amount, we assigned it a value of 0.2. And I'm walking through this stuff because, you know, I'm talking about people that have never coded before in their life. I'm trying to walk you through this. This kind of, at least as far as the Shadertoy is new to me too, so I'm kind of just walking through all the stuff. So color.z, that's going to be the last value that we assigned the color value, is going to equal the blue amount, which we gave in a value, float value of 0.9 up here, right? Okay, so we assigned the color variable for the red amount, the green amount, and blue amount. Okay, and now we only have to assign the last thing that we created, right, which would be the alpha channel. So we create a alpha variable of type float and assign it the value of 1.0. And finally, we create another variable that's going to be a vector 4 that holds 4 different float values, right? And we're going to assign it a vector 4 that has all of the values of color, which at this point we know is going to be our red, our green, and our blue amount, and our alpha. And the alpha, of course, is going to be 1. So we assigned all those to this pixel value. So now all we need to do is down here say the frag color now equals everything that's in this pixel variable, which is, of course, your red, green, and blue channels and your alpha channel. So I guess this is just a long way to kind of walk you through the exact same thing that we've done in the first 3 exercises. But this should work fine in Natron. So let's take a look and make sure it does. We should get a purple color here. Highlight all that, press Control V to copy in the new code. Make sure we didn't bring anything before the comments, and we did not. press compile, and there's our purple background right there. So the first 4 we went through, it was pretty quick, but this gives you kind of a basic understanding of the main function and what's going on. That in the main function, we go over that many times to create the image that we want for our background. And that background is going to be defined by a variable that we know now is called frag color. And what type of variable is this again? Right, it's a vector 4. So this frag color has 4 float values in it, right? And for now, we're just calling them a red float, a green, blue, and an alpha channel, right? So that's going to be it for this video. I'm going to stop it, and then we'll continue on in the next video. See you in the next one.